So the first thing we got to do for this is factor the top, because you'll see that it will reduce. So when you factor the numerator, you get x minus 2, x plus 3, or x minus 2, x plus 2 over x plus 2. Which means there's a removable discontinuity, a hole created when this cancels out. So we have a removable discontinuity, or a hole, when x equals, the x plus 2 is what canceled out, so you set x plus 2 equal to 0, which means x equals negative 2. There's a hole at negative 2 comma something. To get that something, we just got to plug in the negative 2 to what's left over. So plug in negative 2. Negative 2 minus 2 is negative 4, so that's our y value. We have a removable discontinuity, a hole in the graph at negative 2, negative 4. Negative 2, negative 4, there's a hole. Now the graph should go through that point. It just does not include the point because it's a hole. It doesn't include it. So now we need x-intercepts and y-intercepts. For your x-intercepts, you set the top equal to 0. So we're going to set the top, which after we reduced it is only x plus 2. Sorry, x minus 2. The part that did not cancel out, x minus 2. Set it equal to 0. So we get an x-intercept at x equals 2. And for your y-intercept, you plug in 0. So if you plug 0 into x minus 2, because you only plug it into what's left over, 0 minus 2 is negative 2 is our y-intercept. Negative 2 is our y-intercept. Positive 2 is our x-intercept. You can tell from that, also we know that the graph is just x minus 2. So it's got a y-intercept of negative 2, and then the slope is up 1 over 1, up 1 over 1. All we got to do is draw our line. Has to go through all those points. It goes up 1 over 1, all the way through the graph. There's our line with our removable discontinuity drawn in there. That's the entire graph, and you're done.